Okay, let's take a look at this question now. A uniform rod AB of length 4A is smoothly hinged to a vertical wall at end A, which means that if I have a wall like this, then I'm going to have a what's that? This, and then at end A, which is at the corner, I have attached a rod like this. All right. Then what I'm going to do is that from here, I'm going to try to do the next thing, which is the rod is held at an angle of angle theta, and at one end of the string is attached to point C on the rod with AC equals to 3A. Now, it says the other end of the string is attached to a point D on the wall with D vertically above A, and such that AC equals to theta. So this is my vertical. This is my vertical, and this is my horizontal. And D is vertically above A, which means that D has to be somewhere here, and obviously because AC is 3A, then it means it is supposed to be here, and then the ACD angle is supposed to be 2 theta. Now, here's the thing. Let's just do a horizontal like this, which is what many people would end up doing in the first run. Now, the problem is if you do it this way, then this is theta, this is also theta, right? However, because this is theta, and due to the fact that this is horizontal, so we have alternate angles being equal. As a result, if I want to do ACD equals to 2 theta, then obviously it has to be a bit larger. So I'm going to put here something like this, not your typical horizontal as we do like this. Then we have, this is going to be 2 theta, and therefore this is my point C, this is my point D, this is my point E. If this is W, then there's in this direction tension T, and the other end of the string is attached to a pocket. And then a particle of weight half W is attached to a rod at P. It is given that tan theta equals to 8 by 15. Okay, so it means that sine theta equals to 8 by 17 and cos theta equals to 15 by 17 whenever we need it. So after that, we have to do the following. Because we have a t and whatnot, I'm going to do the following, which is I'm going to first of all try to make an equation. So for the moment thingy, because it is in equilibrium, then we have this is 3A and this is A. So half W, so it is going to be W cos theta, and this is going to be half W cos theta. So we have here W, T sine 2 theta equals into 3A equals to W cos theta into 2A plus half W cos theta into 2A. Now what we have to do is that we have to make things up a bit. This is going to cancel out. Okay, this is 4A, this is 2. Then we have a T sine 3A T sine 2 theta equals to 2 plus 2, 4 AW cos theta. So it means the A's get cancelled out. And for the sine 2 theta, what I really want to do is I have sine 2 theta equals to 2 sine theta cos theta. I'm just going to use these two and then just move on. But I need to calculate it. So 2 times 8 by 17, 8 by 17, 15 by 17. We get 240 by 289. So we have here 3 times 240t by 289 equals to 4w times 15 by 17. So it means that now I can cancel things out. This is equals to 17, this and that is 5. This is going to be 48. This is going to be 12. So T equals to take 17 to this side, 12 to that, 17 by 12 W. This is my answer. Next up, find the magnitude and direction of the reaction at the hinge. Okay, reaction means that it's going to be upwards. No. Now the way the question says reaction at the hinge, I think it's supposed to be that the reaction is supposed to be off the hinge. The reaction, the hinge experiences. So it means it has to be downwards, not upwards. So it is going to be, if it is acute, then it's supposed to be towards southwest. All right. Or in this direction, basically. If A gets hits upwards and the hinge experiences it downwards. But the way we can find it is like this. For X direction, what we can do is I can just find the resultant of all the different forces, which is, okay, so the only force in the X direction is happening to be minus T minus T cos theta. So because it's trying to experience the force downwards like this, I mean, it is taking downwards, pushing it downwards. I think the normal reaction is still supposed to be downwards, or for the hinge, and for the rod, it's supposed to be upwards, maybe. But we have here in this direction minus T cos theta. And then we have y equals to W, which means the force at A, it is going to be W. I'm just going to first of all find the components. W plus half W, which is, if I consider downward to be positive. Okay, let's just consider upward to be positive first, which is supposed to be T sine 2 theta minus W minus half W. Now I just need to solve for these two. Oh God. So minus T cos 2 theta means this is supposed to be 17 by 12 and cos 2 theta, which means it's supposed to be 1 minus 2 sine 2 theta. What is it? 240 by 289. 1 minus 2, 240 by 289. Whole square. Okay, this is 2 watt. Oh no, it's not cos 2 theta, it's actually just cos theta because I want it in the horizontal direction. So it is supposed to be 1 minus. So it means that I want it in this direction like this, which happens to be just t cos theta in it. So what I have here is t cos theta. So 17 by 12 into 15 by 17. So we have this is 5 This is 4 and these two get cancelled out. So we have a minus 5 by 4. 5 by 4. And then what we have is y equals to t sine 2 theta. So we have t sine theta. So we have 17 by 12, 15, no, 8 by 17 minus 3 by 2 w. And yeah, there's going to be w as well. Then we have 3 by 4w minus 3 by 2w. So we get 5 by 6w minus 5 by 6w. So it's supposed to be in the downward direction that this experiences. So it means that it is supposed to be in this direction and in this direction, which means this direction. However, because this is about the hinge at exact point there, because it's about the hinge, when it comes to hinge, I need to do opposite, which means this direction. Which means that first of all, I need to find out the magnitude. The magnitude is going to be root this whole square by this whole square. So first of all, we have this equals to 25 by 16 plus 25 by 36. We have 1.50 W. All of these have W, by the way. And when it comes to the direction, for that, I need to find theta first of all. This theta equals to tan inverse 5 by 6 by 5 by 4. Five by 6 by 5 by 4 in it. Let me check. 5 by 6 by 5 by 4. 33.7 degrees. Now this is from here to here, but I want it upwards. So it's going to be upwards 33.7 degrees from horizontal. So the trick behind is that we first of all need to find out the components using the horizontal and vertical force. Because this is due to the horizontal, we actually take theta here rather than 2 theta. So we have t cos theta and t sine theta. So we do t cos theta for x and we do t sine theta for these two. So what we've done here is that we've actually found out the reaction force on the rod, which is supposed to be downwards, but on the other hand, for due to the hinge, it's going to be upwards. So that's the thing I've done here. And then we have given the natural length of the string is 2a. So natural length is 2a, extend final length, this L naught, and the new length happens to be, okay, for the new length I have to find it. So this is 3a, this is theta, so this is supposed to be 3a cos theta, or 45a by 17. This is supposed to be 45a. No, actually, not this one, it's actually this one. So it's supposed to be this is 2a, this is 3a. The tension is, what is it again? 17 by 12 W. I just need the final length so that I can find the extension. hold on. Actually, let me tell you. This is supposed to be isosceles, right? Because if this is theta, let's just say this is theta and this is theta, right? Due to horizontal. This is theta, this is theta. If this is 3a, this is supposed to be a length, and then we have this length. All right. If this is one length, this is theta, then due to that, the hypotenuse is going to be the same length, then isn't it? Because both of them are the same angle theta. Both of them have same adjacent, right? If both of them are same adjacent length, the hypotenuse length is also going to be equal. So it means that the final length is supposed to be 3a. So if this is 3a, then extension is supposed to be a. So it means that my tension is supposed to be lambda by L into X, as we know. This is 17 by 12 equals to lambda is what you want to find out. L is my 2a, and then we have here a. So we have lambda equals to 17 by 6. Simple as that. You just need to figure things out from here, actually.